Good evening and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And today I want to continue explaining Pure Mathematics 3, and I want us to go direct to chapter number 7 and example 5 under the subtopic using trigonometric identities. And yes, it is important to note that some trigonometric ratios or identities are not integratable, or rather, you cannot integrate them or differentiate them directly. And as such, it is very important that you are able to rewrite those which cannot be integrated directly in such a way that they will be integratable directly. For example, if you read at the bold there, it's important to note the following: that trigonometric identities can be used to integrate expressions. And this allows an expression that cannot be integrated to be replaced by an identical expression that can be integrated. And that is why we're looking at example. We go directly to example 5. And example 5 directly we're talking about find the integral of tan x respect to x. And you realize that there is no way we can integrate tan squared directly. But if you look at tan squared x, we realize that it can be rewritten in a way we know some identities. For example, we have understood earlier that the sec squared x is exactly equals to 1 plus tan squared of x. And from there, we can make tan squared the subject of the formula, because we know very well that the sec squared can be integrated. And it goes without saying that the tan squared of x is the sec squared of x minus a 1. So it goes without saying that the integral of the tangent squared of x with respect to x is exactly equals to the integral of the sec squared of x minus 1, of course, with respect to x. And fine, this we can clean up this relationship or this expression, because we can integrate each term at a time, or rather we can even write it in form of the integral of the sec squared of x minus the integral of 1. Of course, both of them with respect to x. This is with respect to x, and this is with respect to x. But directly, we all know the integral of sec squared x. Of course, if you go to the previous page, that is page, you can talk about page 147, you will look at a relationship number 6, that the integral of sec squared x is by itself tangent x, or rather tan x. So straight away, this is going to be the tan of x minus, of course, the integral of 1 is x. Of course, everything at the end of it all, we have to add c, because it was not, it didn't have limit. It didn't have limit. So that is it, and that's the end of that example. So again, visit my YouTube channel and subscribe and share widely, and let's see how we can help each other out. All right.